Okay, good. Thanks, Andre. So yeah, I've been given the pleasure of doing the introduction. So firstly, thanks for your time today to listen to this. You're kind of our internal clients, which I think the way sort of the lens and the behaviour is what we need to have in terms of within Miyamoto. So that's great. So we've got 4 parts to our sort of presentation today. Andreas is going to start off with a bit of a technical summary around our capability and what we can offer in terms of a service offering. Charles is then going to move into a bit of a case study. So what does that look like in practicality? And then I'm going to finish at the end with a bit of an add value and client lens section. So hopefully that'll sort of give you a flavour, and then we're hoping that we can sort of move into a bit of a Q&A feedback, which will be very valuable for us to give us some really cues and indicators about what you need as a group, and I guess how we can work better together, and what the client base that you service is after. So that's kind of a bit of a rundown. Again, thank you very much, and I'll hand over to Andreas to kick off.
Thank you, Bruce, and thank you very much, all, and Keith, for organizing that. That's really, really nice, and it's always a pleasure just to see the whole company together and just in a forum like that. And as Bruce says, I mean, this is the exact reason we're going to do a kind of a short presentation. I'm not going to bother you too much with the technical details, because we can demonstrate that we can do whatever is required for the geotechnical engineering, but we can do it in a way that can help the end product, can help the structural engineers to do their work and all that kind of stuff. And we thought that it's better, instead of me talking about the technical capabilities, to have Charles to present the work that we did in the past, as Jeff said about the Reno, about the work we did in Indonesia with Mark and others, to the work that we did in Mexico and all that stuff, just to demonstrate that examples, and then open up to discussions that we can even just say that if you even have a recent opportunity or a possibility, that how we can probably help. So I am with Miyamoto nearly 4 years, and I'm the technical director in geotechnical engineering. And now I have the pleasure to say that I'm not alone. There is a team that's supporting me, which I'm really happy and really proud about it. And this is the achievement that, after hard work over the last years and the support from Nick, David, and Keith, of course, and all the people in the US that we work with. So if we can go to the next slide. So this is what we do. Is just a very brief introduction that how the whole approach is just to have the problem, to just understand what is the problem, and then find out the solution that can tailor what is the expectation for the project and what are the expectations of the client. Since our focus is not to find the solution that can fit no matter what, we have to find a solution that's going to be to the budget, understanding the expectations, understanding the codes, the regulations, and everything. So with that aspect, I can say that we can do anything that has to start from very complicated up to the very basic stuff, which is bearing capacities, settlements, doing geotechnical modeling, excavations, numerical analysis results, and all that things that it is even the dynamic analysis of the structure. And this is the thing that we are focusing more, how to collaborate. And Charles will show that exactly with examples, which is kind of a stage, what we have done in the past and what is missing. If we go to the next slide. So the important is just, I wanted to touch a little bit to understand, because that's an important thing, because the two disciplines, we do not understand each other. Our problem is the soil. The soil is something which is extremely variable. It's not like concrete, it's not like steel, it's not like timber. It is highly non-homogeneous soil, and we need to understand the ground profile, which is the most important stuff. And that soil triangle is pretty much the essence of our work, of geotechnical engineering and soil mechanics, which is to find what it is there, which is the thing that you will have from the geotechnical investigation with a basic report that the geotechnical engineers will provide to you. Then the other important stuff is to understand the soil behavior. Like, for example, think about the concrete. Yes, concrete, but what kind of concrete? What is the strength of that? Is it any reinforcement? Is it all that stuff that is relevant, different categories of materials that you probably well known, as that material is not well known, it's very non-homogeneous, anisotropic, So it is a bit of an issue to deal with. So we can determine the material parameters by the laboratory and field testing or by back analysis, just to assume what might be the worst case scenario. For example, this is something that we have discussed in some projects that we have. We know nothing about the ground, but we do have a building that it is over there for the last 60 years. So the basic question, in order to understand how likely might be the bearing capacity, is that, okay, we haven't seen any kind of deformation, so we assume that that foundation behaved perfect in the last 60 years, no settlements, no bearing capacity issues. So what is the loading of that foundation? And if we know the geometry of that foundation, we can infer what is the minimum bearing capacity that we can assume for the ground. And this is what is going to give us the additional tool to go back and judge and criticize the numbers that the geotechnical engineers from the investigation probably gave us, which might provide us something which is not realistic or even very optimistic, depending on what is the nature of the problem. So developing on that and adding a little bit of experience and empiricism and everything, this is how we are going to develop the appropriate model in order to do what is required to resolve and find solutions to the answers that affect the project. So that's the essence of the soil mechanics. And the next slide, sorry for mentioning about the next slide. This is because Charles is controlling our presentation, so that's the reason why. So this is actually explains the difference, and this is where we sometimes are lost, because we see the world in a different view. You see a complicated structure, which is based on a rigid base most of the time, which is fine, it's excellent, that will give you exactly what you need for the structural behavior. We see just a pendulum, we see a mass, which is supported in a very complicated ground, which is not even that horizontal. It might be unidentified, which might have some lenses, might have some stops, might have some bedding planes that it is inclined, might have a fault line, might liquefy, very complicated stuff. So we need to understand each other and we need to work collaboratively in order for us to give you a more, let's assume that you will have for that complicated structure to do a dynamic analysis. We need to give you an input that you can put in your base as a base input for the dynamic analysis that will capture that complicated stuff. Without you, we are having the expectation to understand that, but we're having the expectation that we can work together, understand each other, and provide exactly what is needed, not more, not less. So this is what we can provide of that, and this is an example of what we do. I mean, and this is what is probably most important, because obviously we don't have expectations that you can come to us, so that it's going to be realistic to come to us to let you know about the bearing capacity or the settlement for a structure, because you have people that you are collaborating in the US, which is great, but we can help in some additional questions. Even for a simple project, sometimes you might have something that you want to ask, or you are just bothering and you don't have a way, or you don't have established a communication with your geotechnical engineers or the companies that you are collaborating with. This is where we can help. And this is the geotechnical engineering and the soil foundation structure interaction, how it can be modeled with capturing the complicated soil behavior with a very simple beams for the material properties of the structure. But can give you an idea of how the ground will behave and can give you some additional different springs that you can use in your analysis if you want to use the springs instead of a dynamic analysis, which is going to be more realistic to the anticipated behavior that you are expecting from the ground. So I think this, yeah, and that's another example about numerical analysis, that it is pretty much a parametric study of a slab on a ground, that you will see the shear strains and the deformations, which is on a gravel raft, and then that gravel raft is on piles, and you can see how gradually the deformations are dropping because of that ground treatment that is taking place. Just an example of what we can provide if it's required. So I will pass that now after that, which is another example of a slope stability, which is for static and dynamic analysis. And in the dynamic analysis, which is the third slide, you can see how this is a Newmark type of sliding block that it has been developed. And this is where you can estimate the deformations roughly to have an idea, and we can do a performance-based design, knowing that deformation. And if, for example, we have piles we can put that input as a displacement in the piles and see that if that section that we have selected can accommodate the deformations that we are predicting. So I will pass that here to Charles to continue with some of the examples that we have done, and we will discuss later again. Thank you.
Thanks, Andreas. I'm Charles, Associate Geotechnical Engineer with Miyamoto. Been with Miyamoto about 3 years, but previously worked with Andreas. We probably worked together for about 6 or 7 now. So yeah, I'm just going to run through a few case studies, including a few examples where we've already demonstrated good collaboration with the US offices, and then a couple that we've just undertaken specifically in New Zealand. Hopefully through these case studies, I'll be able to demonstrate the significant benefits to be had by good geotechnical structural collaboration, and the benefits of doing this early on. The earlier the better. And then also why sometimes it just doesn't really matter where you are in the world, whether you're in the US or in New Zealand or anywhere. So the first project here is a project currently under construction in New Mexico. I can't say it's a bit of confidentiality is involved in this project, so I can't say too much about the finer details. In essence, it's the foundation design and retaining wall and anchored retaining wall design for a new satellite launching facility in New Mexico. So we got involved in this one fairly late in the day, as the previous geotechnical engineer on the project dropped out, kind of unknown reasons really. And we worked alongside the LA office with the Punch and the team, and providing just geotechnical advice as and where required. And including we've done an extensive review of the existing data and the existing information from the previous geo, provided bearing capacity assessment and soil springs for the foundations, and then geotechnical parameters for the ground anchor design. As I said, for this one we got involved pretty late in the day, and had we been able to get involved a little bit earlier on, or quite early on, I think we'd have done things quite differently from a geotechnical perspective. Another project, although it's located in Mexico City, we've worked collaboratively with the US and the Mexico offices, and we're looking here at the past and the future performance of an aqueduct, a water pipe running through Mexico City. It's a pretty exciting and challenging project, really. The Mexico City clay is probably one of the most challenging soils in the world to engineer. It's pretty interesting. On the geotechnical side of things, we scoped and managed targeted ground investigations along the pipeline. We undertook an extensive research and data review of all available data on the Mexico clay to try and build our knowledge base up. Used all this information to develop site-specific ground models and geotechnical parameters, and that all feeds into our assessment of why the pipe performed as it did in the past. Probably should say, the pipe suffered significant deformations and failures and ruptures. Figuring out why that happened, and then looking at how it may perform in the future. And the work undertaken for this project is it's very much out of the ordinary. It's not just normal geotechnical engineering, and we kind of had to build our assessment process based on first principles and just engineering fundamentals. So by no means specific to Mexico or anywhere really. We also we provided non-linear vertical springs for the pipe, and also some PY curves for the horizontal. Another interesting project. We looked at the site-specific hazard assessment for the regions, Reno and Sacramento. And in order to do this, we looked at we matched real-life earthquake records with a design spectra, which the structural engineers there used in their dynamic analysis. It's a fairly involved process, fairly tricky to match these real-life earthquake records to a design spectra. It requires careful manipulation. You've got to really know what you're doing.
You need to pause and run.
Oh, okay. So that when we get to this stage, when we've matched some records with a design spectra, we can take it a step further actually, and and look at the specific ground conditions for the site and do more of a site specific analysis and really start providing some real value and some specific info such as shear strains and ground accelerations with depth. This is kind of the next stage that we'd love to get involved with. It's a good project in quite high profile project in Wellington in New Zealand, our capital city in the CBD. So it's seismic strengthening project, and here we worked collaboratively with our in-house structural team. We undertook targeted geotechnical and geophysical investigations, and what we were able to do here was actually reclassify the subsoil class from a C to a D in the New Zealand standards, which meant you know, we had a far more realistic and better understanding of the soil structure interaction, which led to, you know, less conservative and more appropriate structural designs of the strengthening work and significant cost savings. With this project as well, of interest is that this building was actually classified as an earthquake prone building. I'm not sure if you have anything similar in the States, but basically it's the government legislation here is a number of buildings are considered earthquake prone, and they're required to be, the seismic performance or the future seismic performance of the buildings are required to be improved to a set standard and within a defined time frame. Otherwise the building is at risk of being decommissioned. So we were able to actually, through our geotechnical work, we were able to justify that the building's not actually earthquake prone. So just, yeah, without really any structural involvement there, just a good understanding of the ground, how the building would perform in an earthquake, we were able to remove that classification, which is pretty big, really. This project is it's a pretty large anchored retaining wall. Forms part of the kind of enabling works for a multi-story, multi-building residential and commercial development down on the lakefront. Yeah, here we actually were, so Miyamoto were the geotechnical engineers on the project. However, we worked with external structural and external other parties. So yeah, it's just an example of us working collaboratively with, you know, with other offices, and the various disciplines were spread around the country as well. So of specific note here is that we actually undertook all of the ground anchor design in accordance with American standards, the FHWA. Up there in my estimation, it's very good standards. Another project, this forms part of a pretty significant recent project in New Zealand. It's part of a large road realignment scheme, and it was required due to the devastating effects of the Kaikoura earthquake back in 2016. So that was a 7.8 magnitude earthquake, very good shake, and it devastated, you know, amongst significant other damage, it devastated a significant section of the New Zealand's transport corridor down the east coast of the South Island. Pretty damaging, pretty devastating. Yeah, so this was we were looking at about 2 kilometers of road realignment, for which we designed some new seawalls. These comprised a mechanically stabilized earth wall with mass concrete facing blocks. And the whole lot's all structurally connected together. The geogrid here used as essentially a structural material used to reinforce the soil. So, you know, soil structure interaction for me is one of its finest. The whole thing, yeah, as I say, the whole thing's designed to move, to get to hold together. And in an earthquake, in a decent earthquake, it's designed to slide as a block, whilst maintaining all of the internal stability. So it was quite a cool design. Pretty proud of that one. Again, for major parts of the design, we also used American standards. We used the AASHTO standards for this. This is a nice project that myself and Andreas were heavily involved with, actually before our time in Miyamoto, but you know, you can see we're still operating together. It's a design of a new bridge, replacement bridge. And it included our major involvement. Well, my major involvement was the bridge abutments. And again, we design these mostly based on American standards. Right, so we don't just do all the big high profile stuff. You know, our kind of bread and butter work is, you know, residential and commercial developments. And, you know, the geotechnical structural interaction is just as important here as it is for any of the big projects. You know, recently we've designed some collaboratively designed foundations for heavyweight buildings on soft ground, buildings over liquefiable soils, retaining walls with sort of out of the ordinary tolerable deformations. So we can do some quite cool stuff, and yeah, working collaboratively is the key to all of that. So my final slide, I've just not strictly structural related, because at this stage of the land development, we don't really have structures in mind. But you know, this is an area that we've had significant success over the recent years in providing value engineered solutions with, you know, more innovative or clever thinking in ways to actually develop land, and you know, getting a real thorough understanding of the ground conditions of the site and how it's likely to perform in the future, both seismic and static conditions. You know, we're able to be less conservative in the design of what goes on top. Just as a little example, one of the projects showing up on the screen there, we were able to save around $1 million New Zealand dollars in ground improvement and foundation costs. And that's just from really smarter ways of doing things, more interrogation of the data, and a better understanding of the actual issues that the site has. These type of cost savings are often the go, no go for a development. So it may make the project economically viable just by having a better understanding of the ground. That's me, thank you, and over to you, Bruce.
Cheers, Charles. So bit of background about myself. I've been with Miyamoto for a year now, really enjoying it. I love the client side interaction, but for the last 20 years I have been in the geotechnics, I guess, delivery space. So within this section, I just wanted to kind of run through some add value points that we saw of integrating the two service offerings together. And really, when we talk about that collaboration, it's about having an integrated approach, in our opinion, and providing that project clarity that doesn't necessarily get given if we're working across organisations. It's just an additional barrier that we can present as an add value. From a client perspective, again, the financial contracts, having a singular point of contact for those financial contracts is sometimes an advantage to our clients. But everything we talked about in terms of, or Andreas and Charles talked about in terms of the collaboration, in my mind, is really about optimizing the foundation designs and what we do. Because when you look at projects, I've been a project manager for a couple of years in my career, and you really can't spend enough on design if you're saving in construction, because the ratio is, you know, it can be up to 10-to-1 in terms of savings. So if we can demonstrate that an integrated solution between geotechnical engineers and structural engineers will provide that construction work savings, in my opinion, it's, you know, it might not be 10 times, but it's definitely significant compared to the expenditure. Another point to consider is the kind of single source of truth post-construction that a lot of people don't think about. We're kind of moving into a world where, you know, we don't just kind of take a couple of as-builts and put them in the bottom drawer and pull the council files when something goes wrong. With BIM coming on board with integrated design, there's a real advantage of that single source of truth. And when you look at your multidisciplinary teams, you know, it's quite hard getting even a couple of disciplines to stitch together from a client perspective. But if we say, look, we've got the structural geotechnical component nailed in one sort of service offering, and by the way, we can also integrate with civils, then as a project manager or a client, I think that's quite attractive, especially seeing we can still keep that boutique specialist feel, as opposed to you know, give me your project. I'm a large multidisciplinary consultancy, and you won't see it until it's, you know, past its time frame and over cost. So I think it's a nice mix. Next slide, Charles. So when you look at the client messaging, a couple of things to think about. In my experience, one of the good ways of integrating another service offering into a proposal without distracting is just to have an add value section. So in all of the proposals we put out, we should be thinking about what our minimum credible scope is in terms of competition with the competitors that we're going up against, but also thinking about an add value section. And that's probably where I see and we see we could kind of start threading in geotechnics into your service offerings as business as usual, because it'll provide an additional value for the client without distracting from your minimal credible scope, which you're kind of living and dying by in your commissions. We can review your projects or your proposals, and that's sort of without cost, a quick review. If we see projects that we can really, that are over designed and that we can really wade into from a geotech perspective before that over design flows through into the structures, I think that's a good way of looking at it. So the international projects, keeping those front of mind as well, and the integrated geotechnical structural service offering, which has really come through in Charles's presentation as being critical. So the rates are pretty competitive, and our dollar is becoming more and more competitive. We've learned recently, yesterday, how many $1 billion the budget is, which would probably seem small fry compared to the US, but you know, we are competitive in terms of cost, and a lot of this can be delivered remotely. In fact, the majority of it. And the other benefit I've found through my career of an integrated service offering is if you can get in early in the project and, you know, even as a bit of a break even or not making a lot of money out of the geotechnical commission, the client's really compelled to keep that service offering in play through the structures. So it can form, you know, an amazing early client engagement within the project life cycle. I.e., you know, we looked at Charles's slide where he had, you know, $1 million savings in the geotechnical portion of land development. Well, it becomes a bit of a no-brainer if you're a client that's got all of the data but we're really keen to get your feedback on projects, on questions, and have a bit of collaborative Q&A. Back to you. Don't know whether you want to take over or you want me to chair this portion of the questions. It's up to you, Kit.
No, it sounds good, man. I mean, last year, I think US office is at least a half dozen projects, mainly for the seismic components of it, and some certain soil structure interactions, you know, it worked really well. And I think to our clients, you know, in the US, especially providing the one-stop shop thing, I think that's a really makes sense, because many of the challenging projects, there are some certain huge issues, you know, we face quite often with the geotechnical solution they, you know, give it to us, you know. I mean, Mark, man, you can probably tell on probably half of the Haiti projects, like pure nightmare, because just outrageous design about foundation makes almost the project impossible to build. And it just make us also looks really bad at the same time, because the clients don't know that, you know, what's the technical difficulty you actually facing it, you know. So having an integrated services or team of a geotechnical as a part of a team to working through for the clients, I think that makes such a huge impact, you know. And also for the business point of view, usually geotechnical engineering comes way before the structural happens, you know. So I think there's a lot of that type of safety can be provided if we can provide this kind of service in the US. So basically, the whole thing was that last year we just kind of started off, after the global meeting we had, and we had a half dozen projects in the US, and it went really well. So that's what the whole thing is actually come from. So you all know what is the geotechnical engineering secret, you notice. It's essentially what it is the soil structure interaction. That's exactly that part we miss all the time. That's why it's so expensive out there. And then potentially we're creating dangerous condition too, by the way. So having a much more in-depth understanding of a soil structure interaction, geotechnical components of it, I think we can provide it a much safer and more cost-effective, actually, the projects to our clients. And many projects we do face the difficulties. Jeff, you want to add something?
Yeah, I do actually. I think just to add to what you said, Kid, and kind of touch on what Bruce said, that the interaction between the structural group and the geotechnical seismology group is key, that you guys provide, that is for the most part lacking here in the US. There's some very good seismologists and some very good soil structure interaction people on the geotechnical side, but it's rare that they're really conversant with the structural engineering language and the building above. So it's just it's something we don't have here. So I think it's a huge add that you guys provide, is to us as an integrated team. So we've had some very good success in the projects you guys have helped us out on. So we're obviously looking for more and to provide that level of service to our clients. So it's been very good. We just need to do a lot more of it.
Yeah.
Just to add what Jeff and Kit said, especially for that thing that sometimes you end up with some huge foundations and everything. This is because sometimes the geotechnical engineers do not ask the right questions, and they just provide you with something which is huge and has to be huge because of that. And the right question at some point is that what is the performance expectations? And that can actually bring things back to real, because here we have, for example, they want to build something on a 300 kPa of bearing capacity, which is what it's called good ground. If you don't have that, in order to fulfill that requirement, you need to have huge foundations, obviously. The question is that, okay, how much is the loading? So what is the performance expectations in terms of settlements or anything that we can design for that? And that means that you can have a solution which is not going to be unrealistic. That's a simple story house is not a nuclear power plant to have huge foundations or piles or anything, unless this is the expectation and this is what is required. And we have seen that very often, and works the other way as well. It's you to ask the right question and challenge the geotechnical engineers, because sometimes we're just hiding behind our bubble. And the example probably in the States, which is more important, is they are probably hiding behind because they are afraid of lawsuits and the liabilities that they are facing. And if they don't have that clear, they will have to be extremely conservative just for their peace of mind.
That's really true, Andreas. I mean, we see that all the time. Almost all the geotechnical engineers, at least in Southern California that we deal with, they'll basically design for initial settlement during construction, give us a very low bearing pressure if it's a spread footing, and they don't usually go much beyond that for that very reason. They're driven to be conservative because for a lot of structures, a basic geotechnical report is a kind of a commoditized item. They're beaten down on their fees, and then you get what you pay for. But on the more advanced and sophisticated projects where there's a lot of dollars at stake, it's really worth having somebody that knows what they're doing and is willing to really figure out the actuality of the project and the problems.
That's a good point, Jeff. That we've come up against that in the New Zealand market quite a bit, where you talk about that commoditized component to it. So we compete as geotechnical engineers, and when we put in a proposal, we need to compete at that level. So we're going in at that commoditized price, but then we're also, and this is the add value that Bruce was talking about, we're also writing into our proposals the add value component. So the way we look at it is, let's win the cheap project, and once we get into it, we can see if there's value to be added to it, and at that point you've got the job. You can then go and talk to the client and say, hey, if we spend a little bit more money on this, this is the likely outcome and this is the benefits that you're going to get. And once you start building a relationship with a client like that,
from at that stage. You know, and you've seen some of the examples. It doesn't just flow into larger geotechnical scope of work. It flows in. You just get given the structural work as well, because the client sees you as a savior.
Yeah. Hey, by the way, the New Zealand office has an affiliation with California licensed geotechnical engineers, so they can basically see over that, just for your information.
Yeah, no.
We need a kind of thing signed in as well as kind of go beyond you know, what we've been doing. You know, as long as we're doing like the site-specific inspection stuff like that, you know, as a civil engineers, we can sign off. Once we get into actual geotechnical foundation design, we definitely need a geotechnical signature on there. Anyway, hey, Ivan, do you guys have any struggle out there in an island in Puerto Rico of the geotechnical? Got a lot of unique soil in area of the world.
We have all type of soils depending on what part of the island you are. The expertise is we have good geotechnical firms, and they're geo-affiliated with companies in the U.S. But it's definitely a market that, you know, the level, what I saw shortly on the presentation, you know, we're more typical geotechnical. In that type of more specific cases or more sophisticated cases, usually they get geotechnical from the States. So definitely a good market here for having that option when the specific project comes. I mean, there's an opening here, like everything. Where, you know, we're not optimized, and usually when it gets to be really hard, especially what we're doing now with the Highway Authority, there's a lot of projects there that I think this information will really come, you know, useful, and we'll be able to work on those because there's a big need for those here.
Yeah.
Mm-hmm.
Yeah, I mean, just this is Mark jumping in here. So, Kit, you'd mentioned Haiti earlier, and I kind of think back to that General Hospital project from, like, I don't know, 6-7 years ago. And initially, they designed the entire project on piles. It's like 250,000 square foot hospital, 2- and 3-story buildings, and they put the entire project on piles. It ended up with kind of some more advanced geotechnical analysis and design, and doing some settlement analysis. We were able to get the building off of piles and onto spread footings, and it ended up saving, like, you know, millions of dollars for the contractor in construction costs.
I remember that.
And also construction duration as well. I mean, they had programmed like 800 piles or some crazy number. I can't remember what it was. 2,000 piles, some ridiculous thing.
Yeah, for 2-story buildings. Yeah.
For 2-story buildings. And so, you know, this era of going to conservatism, it's just crazy, and it can really just kill projects. And then the other side of it we see a lot of people just defaulting back to like mat foundations, which sure they have their place, but a mat foundation isn't necessarily a good thing, because when you're putting like a 1-story building on it, you end up increasing soil stresses drastically because the mat itself weighs more than the damn building. So, you know, over conservatism isn't a good thing, and it's really rampant in the geotechnical field. So it's good to have that kind of ability in house, where we can do like we do with the structural and look for better performance on the geotechnical side too.
Yeah. Hey, Jay, you're back. What's your thought about this whole thing?
Say that again, Kit. Was that for me?
Yeah, it's for you.
I think there's a lot of potential and a lot of opportunity. I just haven't personally been involved in taking advantage of it yet, but I just think that it's something we need to incorporate more. There's a clear path for us to take advantage of it, and I think it would be well received if it's presented in the right way.
You know, our older geotechnical mentor, Dr. J.P. Singh, who we worked with him for 30-some years. You know, he's been kind of retirement now, but he always said to me, geotechnical and the structural engineering has to be shake hands. That's the whole thing he's coming from, kind of working together. It's not like I give you a report and design it. has to be like working through from day one. That was a whole kind of picture Andre showed how, you know, how geotechnical engineers see the world, how structural engineers see the world is completely different, you know, that need to be connected. That's why that sometimes there's a huge disconnect in the projects essentially.
Yeah, I think it's pretty rare that we spend a lot of time with our geotech. We get handed a report, at least in the US, on conventional projects. We get handed a report and we deal with the findings. There's not a lot of as much interaction as there should be, or even early upfront discussions about the why behind, you know, what we're trying to accomplish.
I think huge changes happened just fairly recently in the structural engineering world, right? Now that we look deformation-based engineering and performance-based engineering and stuff like that, especially the retrofit and a new bigger construction, we basically looked at how actually structure be deformed. That's the whole design philosophies look like. Our problem is that when we model the thing, we model as a fixed base, which is completely untrue. So whenever we do a deformation engineering to see that there was an inelastic behavior going in the structural system, we're completely off the mark because soil itself is actually moving with you, you know? So that soil structure interaction component is so critical whenever we actually use the deformation-based engineering, you know, which actually we do quite a bit for, you know, larger buildings when we get into even smaller buildings. So I think the soil structure interaction components, we'll have to model not only the building itself, but model the whole thing. Essentially, the geotechnical engineers, our guys going to provide you the soil springs. That's how we actually model into it. Some cases even soil dampening components of it. You know, you use JP since that and the kid, you notice that, oh, you know, if the magnitude is 7.5 coming through, you notice that not 100% buildings collapse. Because the reason is because those buildings has a basement, and the basement that has a lot of friction between the soil to that, so that absorb a lot of energy. That's why those buildings doesn't collapse. You know, it's so truth about that, but we don't really capture that kind of effect actually. So that's why if we want to provide good engineering to the clients, we definitely have to look into not only the structural engineering components, but also geotechnical engineering of it. That's why it's so, I think, critical to have our experts in-house like this.
Yeah, and just to add on that, Kit, that's because sometimes people are confusing and they're just thinking that this is a complicated exercise, the soil structure interaction. The soil structure interaction is not necessarily the dynamic analysis and the full numerical modeling or anything like that. It can be a very simple phone call. That's the interaction that we are speaking about. It's just communicating what is the problem what the structural engineer needs to deal with, because you know probably better than the geotechnical engineers what is the expectations of the behavior. So you know the behavior, you know how your foundations might operate in static conditions or in dynamic conditions, and this is the thing that needs to be communicated back to the geotechnical engineers to provide a solution for what might be the potential issues.
That's right. Since you don't know that what we're doing, you put some safety factors on it, right? Like you kind of make a judgment. Okay, maybe 1 inch settlement or 2 centimeter settlement is okay or whatever, right? And to do that, you basically put some safety factor of 5 or something, maybe 10 sometimes, because you don't know what we're facing really, and you don't know if the 1 inch settlement is good or bad. You know what I'm saying? But if you have a discussion going through, okay, we can take a 1/2 inch settlement. Okay, let's see what we're talking about. It's not a safety factor. It's about the deformation coverage of a soil itself that we need to capture. But that itself is very simple nowadays, you know. ETAPS have 2000s. You can just do you don't have to do the dynamic analysis anymore. You can just do that. They really push over to really see that what is a settlement characters look like. And New Zealand, we collaborated. What was it? Ghazni Street. It was the same thing. It was a small building, small heritage building, like a little building, right? And having a soil structure interaction into the model, it just that we're able to capture exactly what's going on in the building system itself, and actually it made a huge difference in the cost of construction and safety of construction.
I think
so definitely opportunities everywhere.
Jay's point, Kip, before that, you know, in the States, essentially what you end up with is a geotechnical report, and that's about it, and not a lot of interaction. And I think it's not just limited to the States, it's pretty well a global phenomenon that essentially here's a report, take the findings from the report, So people believe there's been integration between structural and geotech, and it doesn't really exist. And even within the same firm on the same appointment on the same project, there'll be silos within those entities and they really don't integrate. They'll do a structural. I mean, rarely they do, and sometimes they do, but generally you'll get a structural, you get a geotechnical, but they don't take the findings to demonstrate the true value. And that's really the opportunity we have here. And, you know, the emphasis that Andreas and yourself are making on the degree of detail that's required, you know, varies greatly to minimal to major, depending on the project and depending on the benefits. But it's something that really is not undertaken. I mean, if you look at it from the PM side, you generally have to bash heads together of people so that they'll actually consider other people, consider the findings from others, but the benefits are phenomenal.
Yeah. Chewy or Dan from Mexico City or Vegas, you guys got some thoughts on this? What we're doing?
Glad to have joined you. I was meeting with Jim Van Compernoll, and I can tell you about that later, but that went very, very well.
By the way, it's who you're looking here is Dan Campbell. He is a principal at newly formed Las Vegas office. And our office at the 51st level of the downtown Las Vegas, as you can see.
Yeah, that's where it is.
What do you think, Dan? I mean, a geotechnical aspect of it, you know, Vegas does have a pretty intense issues out there.
They do. There's a couple of varied issues. One is we have a number of faults running through the valley. We have some extreme expansive soils in the northern part of the valley, and we have caliche lenses in a number of places throughout the valley, which, you know, it makes it hard to judge. Sometimes there's potential for differential settlement and so on. So there are some challenges here. You know, we've managed to, there's also quite a bit of, believe it or not, there's quite a bit of water close to the surface near downtown Las Vegas. It can be as close as 10 and 12 feet under the surface. So there's quite a bit of water there. So
yeah, your pyramid in Vegas has been sinking for the last 30 years.
Yeah, yeah. So, you know, I didn't catch the first part of it, for which I apologize, but there's quite a bit of opportunity to work closely with and or create geotechnical opportunities here.
Anybody else have any questions, any comments, thoughts?
Jeff, this is Ed. I got a question for you. Did you go with me to the homeowners association meeting at the Montage where I live?
I did not. Was that Richard maybe?
I'm just trying to remember who it was, because they're starting to look at structural, or well, geotechnical too, but you know, the soil condition under the building and what the shape of the building is in, because we're about to do another deep dive on the post-earthquake analysis of this building, sort of like what we're doing for the city hall.
Okay.
Ed, I think that was me, Ken.
That's right. It was Ken. Yeah.
Is it you, Ken?
Yeah.
All right. Well, we have to. I don't know if you remember. Did you take a look at the drawings when you were looking at that?
Yes, I did. I remember that. You know, it was billed as a seismically renovated building, but only a portion of it was renovated.
Exactly. And you know, there are some issues that have come up along the way since it was converted to a condominium, and now's a good time to get back involved with those guys. So whenever whoever's going to be near Reno, I want them to come meet with the homeowners association.
Okay.
So I mean, Jeff, it could be you or it could be Ken. I don't. It's up to you guys. You guys decide. It's whoever's going to be here first, and I'll set up the meeting.
Right.
Jeff,
Try
I'll
and
talk.
get the drawings to look at beforehand.
I think we have the drawings in a file somewhere, Ed. I think we wrote a proposal back, I don't know, 3-4 years ago, and
Yeah, I think you
I think
did.
we opened a file on it. So
Why
I
don't
think we have.
you take a look? Somebody take a look and see what you have, and what more you need to be able to do a proper analysis of this place.
I think, Ken, correct me if I'm wrong, but I think we have the renovation drawings when they added the 2 stories and the elevators, and I don't think we have the original drawings of the original tower.
That could very well be, because I live in the added floors.
Boy.
I think time started getting close to top of hour here, so maybe we should.
Yeah.
Are there any questions or comments to our geotechnical experts here?
Yeah, I would like to comment about the Mexico City. As
That's
you
it.
know, we have a very bad soil because we build a city in an ancient lake. So here in Mexico, we have a very good opportunity because the geotechnical engineers here in Mexico are very conservative. And in some cases, we have seen that in the buildings that they design here in Mexico City, they overestimate the loads, and they make the foundations very heavy and very expensive. So what I have seen here is that maybe we can make a difference between our competence, because if we make a very good geotechnical studies or soil mechanics studies, we can give some cheaper solutions for our clients. So here in Mexico, we have that kind of problems. I have seen over-designed structures, and I think that we can provide additional solutions for our potential clients. And we have in Mexico, we have, as Andreas know, we have in Mexico very competitive engineers. We have many experts here, but maybe we are not. We have no a local engineer who can help us with some designs. And also we have the issue with the price, because in Mexico we have a very low prices compared with another countries. That's
about 1/5.
Yeah.
Hard to compete on the environment.
That would be an advantage if we hire Mexican geotechnical engineers. That would be a very good option for us with the supervision from New Zealand.
That's how to do it.
Okay.
That's how to do it.
Yeah, thank you, Tsui. I just want to add that the quality, though, that the research has been taking on, and what I have seen from some local engineers, they are very knowledgeable, and even in the authorities. And also, I'm still impressed about what I see in that laboratory that we visit together. Amazing work with basic stuff, and they managed to do very sophisticated testing. I mean, I have never seen that in any other parts of the world. So definitely there is some improvement, because there is a lot of research, there is a lot of applications, and we have just seen that demonstrate with that Mexico projects for the Aqueduct. With only 10 CVTs, we managed to provide Conagua with dynamic values and parameters that they were so keen, and it's not necessarily feasible that somebody can do that only with a handful number of CVTs.
Yeah, here in Mexico, we have very good labs, very good engineers in geotechnical, as you know. And I think that we have a very good opportunity because of our coast here in Mexico.
Cool. Are there any questions or comments to anyone? All right. If it's not, the Jeff and Jay and myself, our geotechnical team is we're going to meet. We're going to come up to a certain idea of the after this call, and we'll come up to certain I guess business plan how we can actually help our clients in the U.S. and places for this coming year. So that's we're going to do that probably next week. All right. So Bruce, Andres, Charles, anything else?
No, thank you very much all for attending that. It's really, really great to see all of you.
Yeah.
Yeah, thanks very much for your time and knowledge.
Thanks so much, guys.
Cheers.
Yay! Kiwi people.
Go All Blacks.
All right, guys.
All right.
Okay.
Easy.
Cheers, guys.
Cheers.
Bye-bye.
Thank you.
Adios. Adios, amigos.
Adios. Adios, amigo.
Jeff, get back to me on the Reno, okay? I think he's gone.